Okay, so we'll go back to our step-by-step process. The first one is to identify the mesh currents. And again, none of the resistors got numbers here, so I'll call them 1, 2, and 3. And so then I1 clockwise, I2 clockwise, I3 clockwise. So if we're going to put our polarities on there, this time, this one's a little bit easier. I think we only got that one shared resistor down there. The sources, however, we got to watch those polarities with respect to the direction we're going in. For I1 then, it will be going up through the 1 ohm, so polarity positive on the bottom. Left to right through the 30 ohms, so positive on the left. Oh, and of course the 6 ohm resistor is shared too. I1 goes down through him, so positive on the top. For I2 now, up through the 6 ohms, so positive on the bottom from that side. The 2 ohm resistor, I2 down through there, so positive on the top. For the 4 ohm resistor, I through from right to left, so positive on the right. Okay, I3 then, through the 2 ohm in that mesh, up, so positive on the bottom. The 4 ohm, left to right, so positive on the left. The 3 ohm, right to left, so positive on the right. Okay, now we'll start then with mesh 1, lower left hand corner. So 1 ohm resistor, it's a voltage drop, minus I1. The 50 volt source in the direction of I1, which is clockwise, we're going up there, so that's a volt from a negative to a positive, it's a voltage rise. Plus 50. For the 3 ohm resistor now, again, negative 3 times I1. For the 6 ohm resistor, he's shared resistor from the I1 side, negative 6 I1. And so then the polarity for I1, if we're going down from the mesh 2 side, that's a rise, so plus 6 I2. And the, when they're shared like that, the two terms that they put in the equation, they're always opposite polarity. So the second one will always be positive, right? Okay, so now, next we come to the 20 volt source. We're going from a positive to a negative, right? So across there, that's a negative 20. And next we're coming to the 30 volt source, and again, that's a positive to a negative. So that's a subtract 30. Now we're back to our starting point, so our sum is equal to 0. And so you'll notice for this one now that we had a plus 50, a negative 20, and a negative 30. So they're basically canceling each other out completely. And so that means that we go back then to writing our equation. I1, we have negative 1, negative 3, negative 6. So that's negative 10 times I1 plus 6 times I2, and no shared resistors with mesh 3 there. So our sum now equal to 0, and we call that equation 1. Okay, mesh 2. So mesh 2, lower left hand corner, we have a first thing is a plus 20 volts. Then we have our shared resistor, and so from the I2 side, negative 6 I2. So then from the other side, positive, so plus 6 times I1. For the 30 volt, we're going from left to right, so that's a voltage rise. So we have plus 30. Okay, now on the next resistor is 2 ohms. It's not shared, of course, so minus 2 times I2 is the only term for that one. Then we have the 4 ohm resistor, minus 4 times I2, and mesh current I3 also goes through there, and so that will be plus 4 times I3. That brings us back to our starting point, so that sum is equal to 0. Now, let's think about our terms with I1 in them. There's only that one term there, so we have 6 I1. I2 passes through all the resistors in that mesh, so we have 12, right? Minus 6, minus 2, minus 4. So minus 12 times I2. Plus 4 times I3, and that takes care now of all the terms with variables in there. So is equal to our voltage. We have 20 plus 30, so that's plus 50. We're bringing that across the equal sign. We make that negative, so equals negative 50. And that is equation 2. Okay, mesh 3. Now, lower left-hand corner, we got the 2 ohm resistor, minus 2 times I3. Of course, that one's not shared. We don't have any shared resistors with mesh 1 now. We're going left to right across that voltage source, so that's a rise in potential. Plus 30. Our next resistor is the 4 ohm. From the mesh 3 side, we have negative 4 times I3. And of course, that one is shared with mesh 2. So that means plus 4 times I2. Okay, so next then we have our 3 ohm resistor. It's not shared, so just minus 3 times I3. And now we come to the 50 volt source, and we're going right to left across there. So that's a plus to a negative, or a drop in potential. So minus 50 brings us back to our starting point. Our sum then is equal to 0. Okay, so no I1 terms in this expression. One shared resistor, of course, with mesh 2, so we have 4 times I2. And of course, of the resistors that I3 passes through, 9 ohms, so minus 9. Just let me fix that. So minus 9 times I3 is equal to, we have a plus 30 and a negative 50, so that's negative 20. We bring that across the equal sign, it becomes plus 20. So we have 4I2, subtract 9, I3 is equal to plus 20. Now, from a point of view of substitution, this equation has no I3 in it. This equation has no I1 in it. And so we should solve this one for I1 in terms of I2, solve this one for I3 in terms of I2, substitute both of them into equation 2, come up with a value from I2. Go back to equation 1, come up with a value for I1, go back to equation 3, come up with a value for I3. So substitution for those types, where only one equation got all 3 variables, is relatively straightforward. There's a pattern that you can follow there, and that gets you through. For the calculator solution for this one, we have from equation 1, minus 10 for I1, 6 for I2, no term with I3, so be sure to put in your 0 for that. For equation 2, we have 6 times I1, we have minus 12 times I2, and we have 4 times I3. For our third equation, we have no term with I1, so we put in our 0 for that. We have 4 times I2, and we have negative 9 times I3. Take the inverse of that matrix, multiply it by the matrix of constants. For equation 1, we have a 0. For equation 2, we have a negative 50. For equation 3, we have a positive 20. Okay, so when you put that into your calculator, you should come up with some nice round numbers for that one. 0.600. Okay, so only one of them nice rounding number, 6.208, and no, wait, I made a mistake there. This is not correct for I1. For I1, you should have came up with 3.725 amps, 6.208 amps, and for I3, 0.537 amps. So we keep, yeah, 3 significant digits for the last one, and we get 3 places after the decimal for addition and subtraction. Means these here got 4, right? And of course, that represents I1, I2, and I3, as they've been defined in our mesh equations. Okay, so now step 5 is to come up with the solution to your equation. So whether you use substitution or Cramer's rule or not, you got this. And now the answer to the question is Ix here. And so Ix, the direction of Ix agrees with I3, and that's a shared branch. And so I2 goes through there, but in the opposite direction from Ix. So we got subtract I2. And so Ix now has a value of 0.537, subtract 6.208, and you'll see that that Ix again comes out to have a negative value. And so the reality is that that means that Ix really goes through that 4 ohm resistor from right to left, right? And so Ix is equal to negative 5.671 amps. And so again, that means that it goes from right to left as opposed to the indicated direction. And the negative sign always means that the indicated direction was incorrect.